Hello everyone. How are you all? I hope you all are fine and safe. Well, I'm just going to continue the lecture on gamma function. And actually, I have just uploaded the first video of gamma function, that is introduction to gamma function, right? Actually, my phone got heat up, that's why I cannot record it on the blackboards. But I'm just looking to record it on the tablet itself, right? So in this video we are just going to continue this lecture, the continue this series. So in the first video what we did is we just derived that gamma of n was the integral from 0 to infinity of x to the n minus 1 e to the minus x dx, right? Okay, so this was I just proved it down in that video. Please check that out if you haven't checked it out yet. And now we're just going to just continue right from here, right? Okay, so in that video I'm not sure, but maybe I'm sure that gamma of n, I just showed it to you. Gamma of n is n minus 1 factorial, right? So yeah, okay. So yeah, okay, so let's just continue from here itself, right? And now let's just replace n with n plus 1, right? So gamma of n plus 1 becomes n plus 1 minus 1 factorial, that is n factorial, right? It means that gamma of n plus 1 is n factorial. Okay, and what about n factorial? N factorial is n times n minus 1 times n minus 2 times n minus 3 times dot 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 3 times 2 times 1, right? I hope you guys are familiar with this, right? Okay, so I'm assuming that this part is left alone in a single term, that is it's n minus 1 factorial, right? I hope you can understand that. So n factorial is n times n minus 1 factorial. Okay, so n factorial is n times, what is n minus 1 factorial? From here you can say that it's gamma of n. So it's gamma of n. So yeah, so n factorial is n times gamma of n, right? And what is n factorial? From here, gamma of n plus 1. So from here you can say that gamma of n plus 1 is n times gamma of n. This is a very important formula, and this is literally very important. Please note it down, because this is the most basic formula that you need to remember as much as early as possible, right? Yeah, and now I'm just going to have a look at this itself. Okay, so I'm having gamma of n plus 1 equals n times gamma of n. Okay, what about gamma of n plus 2? It's n times gamma of n plus 1, right? Oh, sorry. Actually, what I'm talking about is n plus 1 n plus 1, replace n plus 1 with n plus 2, right? So how you gonna do that? Or maybe, oh, I'm really sorry guys, put n equals n plus 1. That's it, what I'm talking about. That's what I'm talking about. So it becomes n plus 1 equals n plus 1 times gamma of n plus 1, right? Okay, so it becomes gamma of n plus 2 is n plus 1 times gamma of n plus 1, right? And what's gamma of n plus 1 from here? Just plug it down. So this becomes gamma of n plus 2 is n plus 1 times n and times gamma of n. It basically, what it mean is this. right? Okay, and if you have a look at when you just have a look of this, when plug n equals n plus 2, like just replace it with that inside this one, right? So when you plug n should be replaced with n plus 2, so this becomes gamma of n plus 3. I hope you understand that. And this becomes gamma of n plus 2 times gamma of n plus 2. And from here you can say that gamma of n plus 3 is n plus 2 times n plus 1 times gamma of n. So basically what it means is this one, n times n plus 1 times n plus 2 times gamma of n, right? Okay, so do you feel any kind of like connection in between these things? Well, I feel that. So let's talk about a generalization form, that is gamma of n plus z, right? So what it is n times n plus z minus 1, n plus z minus 2, n plus z minus 3, dot dot dot, and times gamma of, sorry, not z but actually n, right? Okay, and how so? And just be careful that these are the terms z minus 1 times actually. So this is what a generalization form that I personally evaluated or generalized it. Let's just check it down whether it is useful for us or not. Let's plug z equals 2, right? So gamma of n plus 2 is n times n plus 2 minus 1. Be careful that as I told you, this is z minus 1 terms. So 2 minus 1 means the first term only. I'm not talking about this n. This is excluded from these things. So this is first term only, right? So and times this one. So that is gamma of n. So this becomes n times n plus 1 times gamma of n. Let's check this out. And here we did that, right? Okay, for your convenience, let's talk about z equals 3. When you plug z equals 3, so this becomes inside this one and this one, because we are going to take only two terms as 3 minus 1 is 2. So it becomes n times n plus 3 minus 1 times n plus 3 minus 2, and sorry, not dot dot, actually times gamma of n. So this becomes n times n plus 1 times n plus 2 times gamma of 3. Is it? Let's talk about, yeah, gamma of n plus 3, n times n plus 2, 1 times n plus 2 times gamma of n. And actually it's not gamma of 3 but it's gamma of n. And yeah, n times n plus 1 times n plus 2 times gamma of n. That's it. How amazing that is, guys, right? How amazing is that? So yeah, for this video I'm just going to leave it here itself, or I'm just going to bring some videos on gamma function itself. Like I will be talking about some generalization of integrals, and yeah, those integrals are really classic. So just stay tuned for the next video. And yeah, thank you so much. Just continue with me for the journey of the gamma function. Thank you so much. Bye.